Okay, welcome to your first session on algebra. So today we're looking at being able to form and solve equations for linear numeric patterns and apply inverse operations. Before we start, I wanted to look a little bit at some of these words, at some of the vocabulary that we're using. So the very first one I want us to look at is the word equations. Now equations are the problems that we need to solve, is what it is. The next one is linear, which means in a straight line. It comes from the word line, linear. And then numeric patterns are number patterns, okay? Numeric coming from numeral, word for number. So the number patterns in a line, so 3 plus 4 plus 7 is a all in one line, okay? Then, so we're looking at forming equations that sit on a line and involve numbers and patterns. The other part of it, the second part of it, is to apply inverse operations. Now this word inverse is actually meaning the opposite way around. So if, for say, we are looking at what 5 times 3 equals, okay, normally you're looking at what the answer is, so it would be 15. But an inverse operation would be looking for something that is missing, okay, so 5 times something equals 15, and you're looking at, well, I know that 15 divided by 5 is 3. So it's working backwards. Right, so if we just get rid of all that. And the next thing I want us to look at is algebra in general. So you have known algebra for a long time now, and you may not have known that that's the way. So if we look at this equation again, 5 times something equals 15. This is what you sort of would start with algebra. There's a missing number and you're trying to find it. That's pretty much your most basic form of algebra. Okay, as you kind of got up to school, your things are a little bit glitchy. Your square ended up getting turned into a line. Okay, so you ended up with 5 times a line equals 15. Then you might have ended up with just a gap. Okay, now up at our level, what we're looking for is we are looking for to stick a number in, a letter in there. So this is where letters come into maths during algebra. And yeah, I know what you're thinking, the letters, they should be part of reading, but no, they're part of maths. So this is where we just put 5 times, and it can be any random letter. Okay, I could have A in there, equals 15. I could have B, C, D, whatever. Okay, it is up to whoever's choosing it. I could have N for the number. More often than not, though, you will find that they use the letter X, and you'll notice that they use a cursive X, and this is so that these two don't get confused. You don't want it to look like 5 times times. Okay, so that's why they use a cursive X. Now, so what we're going to look at is we're going to look at solving some of these patterns. Okay, so the first one here is a basic pyramid. Okay, the whole way that the pyramid works is that, so Amandeep and Mutu are looking at this number pyramid here, and they're trying to find the next lines, and they're looking at 4 plus 2 equals 6, which is this number here, and then 2 times 3 equals 5, which is that number there. So they've each kind of found one. And then they're looking at 6 plus 5 equals 11. Now with the second one here, they're looking at how would we find this top number without having to work out the middle number? Is there a pattern to this? And if we go through and have a look at it, we go 4 plus 5 equals the 9 that goes up the top. And then the next one, so that's this one here. And then the next one is 5 plus 6, which equals this square here. And that, of course, is 11. So we kind of look at, well, then we move them up and add them together. So what we're doing is we're adding these ones together, whereas we could have just added this sum and this sum together. So the numbers I'm now using are 4 plus 5 plus 5 plus 6. And I want you to tell me, does this equal the same as what this would? I want you to pause it and work it out. I'll do that now. Yeah, so you notice that it equals 20. Right, the next thing I want us to look at is that Motu reckoned it was be 20. Is he right? Well, yes, he is. Okay, and that's how we have worked out the top number. So question B is, how could we have worked out the top number? Well, we're actually adding all of the bottom numbers together, but we realise that that number 5, because it's sitting in between two numbers, we're going to use it more than once. Right, so what I want you to do is I want you to use this pattern, and I want you to figure it out for these two here. So see if you can find the answer to these two questions here. So you need to pause and go and figure them out. Right, so you should have something like this. 6 plus 2 plus 2 plus 9 equals 19. Okay, that's that first one there. 6 plus 2 plus 2 plus 9 equals 19. And then 10 plus 4 plus 4 equals 9. Right, the next one I want you to look at is this one here. So have a think about it. Okay, we're adding in an extra row in here. So there's now 4 rows. So therefore we're going to be using some of these numbers more than once. So I want you to go and have a think about it, and then come and see me in class and see if you can tell me what the answer might be before you move on. Give that a go now. Okay, so what I've done here is I have written down, like we had before, adding the middle numbers in the middle twice to the outside numbers, like we had with the 3-tier ones, so the ones with 2 extra tiers on top. And then let's go through and add them up. So 5 plus 2 is 7. Oh, so make sure I'm on my pen. 2 plus 3 is 5, and 3 plus 1 is 4. So then we go through and, I don't know why that's not working. Right, and so 7 plus 5 is 12, and 5 plus 4 is 9. Alright, and we add those two together, and we go 9 plus 12 is 21. So, am I right? Let's go through and have a look at the bottom. 5 plus 2 is 7, plus 5 is 4, so let's just add these numbers across. So 7, 5 and 4 come to 16. Are we right? No, we're not. Okay, so what sort of numbers are we missing? So it's a difference here of 5. And if I have a look, well, look, here's these two numbers here, add to 5. So maybe the pattern isn't that we add the numbers twice in the middle. Maybe I have to add them 3 times. Let's go and have a look at, I'm going to have a look at this with 3 times. Oh, excuse me, I need to rub it out. Because we're looking for that number 21. So if we go 5 plus 2 plus 2 plus 2, remember we're adding them 3 times now, plus 3 plus 3 plus 3 plus 4, is this going to be 21? I want you to work it out, and you'll notice that yes, it is 21. So the pattern here is that we add in an extra tier, means we need to add in an extra set of those middle numbers. So I want you to do that for the first one, and then I need you to go and look at the rest of this one here, which will be on the follow-up, and then do your follow-up. Thanks, bye.